All right, so this is an introduction to functions, and we are going to understand function notation algebraically and graphically today. There are many characteristics of a function, so let's start with what is a function? A function is simply a relationship between two sets of numbers. It is a relationship between the domain and the range. A function says for each input, we have exactly one output. In less mathematical terms, it means that the x values cannot repeat. The x values cannot repeat. So let's look at this graph. We have this like awkward V-type shaped graph, and if you're looking at it, the x values go from left to right. So do any of those x values repeat? The answer is yes. Yes, they do. So what you have to do is a graph a function? Well, in order to determine if a graph is a function, we are going to use the vertical line test. The vertical line test says that if you can draw a line vertically, which is up and down, oops, that's not very straight, and it crosses the graph in two places, cross one, cross two, then it is not a function. And we can see here that that graph definitely does that, and it crosses in two places multiple times. So therefore, this is not a function. Function notation is the type of notation we are going to be using in this chapter. Function notation is basically a way of replacing y with f of x. So f of x represents function notation, and we read it as the value of f at x, or as I was saying earlier, f of x. So domain and range are a big part of a function. So let's just quickly review what is domain, what is range. Domain is the inputs, typically the x's. So in f of x, x is the domain. F of x is the output, which is the range. So if f of x equals 3x plus 7, and we get asked to find f of 1, what we're going to do is take that 1 and replace the x in our example. So f of 1 becomes 3 times 1 plus 7, or 3 plus 7, which is 10. So f of 1 equals 10. How about f of 4? F of 4, once again, we replace the x with a 4. So we get 3 times 4 plus 7, which is 12 plus 7, which is 19. F of negative 2. So just because it's a negative doesn't change our process. We're going to place the x with a negative 2. So you have 3 times negative 2 plus 7, which is negative 6 plus 7, which is 1. So f of x equals 3x plus 7 represents my function in terms of x. F of 1, f of 4, and f of negative 2 are simply finding the x values, which are 1, 4, and negative 2, and getting their y values, which are 10, 19, and 1. So let's see an example wrote out a little bit differently. F of x equals x plus 1. This is equivalent to saying y equals x plus 1. So f of 2 means you should substitute 2 in place of x. So once again, f of 2 equals 2 plus 1, or 3. G of x equals x cubed minus 2x plus 1. So this is a cubic trinomial because there are 3 terms and it is a degree of 3. We're going to find g of 1, so we're going to plug the 1 in for all of the x's. So you get 1 cubed minus 2 times 1 plus 1, which is 1 minus 2 plus 1, which is 0. Graphs of functions, instead of using domain and range, we use something called the independent and dependent variable. The independent variable is our input or our domain. The dependent variable is the output or the range. So independent is usually x and dependent is usually y. So in a graph, the independent in this case would be the x's, the dependents would be the y's. So x and y give each other their answer together, but y depends, hence being called the dependent, on x. So a question might look like f of 2. So the answer to f of 2 or f of negative 4 is going to depend on x. So f of 2 says you go to x equal 2 on our graph. So x is 2 on this line. So the value when x is 2 of y is right here, which is 2. So f of 2 equals 2. F of negative 4 says we go to negative 4 on x, find the y value. In this case, the y value is on the x-axis, which means the y value is 0. Now, what if I flipped it? What if instead of saying f of negative 4, I say f of x equals negative 4? That's like saying, what is the value of x when y is negative 4? So now we go along the y-axis and we look for y being negative 4, which is along this line here. And we find the x value at which that occurs, which is here. So it occurs when x equals 3. F of x equals negative 1. So again, same idea. Where's the y value negative 1? That's along this line here. So the x value at which it occurs is about 2.5. Okay, so now it's determining what is the question asking. Do I know the difference between the two? So f of negative 2 is asking what is y when x is negative 2. So x is negative 2 here. So my y value is on the x-axis, which makes it 0. F of 1, so that's when x is 1, so that's here. So you go x is 1, go up to the graph, and we see that when x is 1, y is 6. And then determine the value of x for f of x equals negative 2. Well, this is the backwards. This is, okay, where's negative 2 on the y? Here it is. What is the x value? Negative 1.